Hello, for today's video lesson, our topic is I can graph linear inequalities in two variables. So in our last couple lessons, we've been going over kind of linear equations, linear functions, how to graph them, find the slope. So the good news is today we're pretty much just taking what we did before and adding in a few other elements. And we're going to apply them to inequalities. So recall that a linear inequality would be just like an equation, except it would be, say, y is greater than 1/2 x plus 4. So we're interested today in graphing these. So when you graph a linear inequality, we'd start out by graphing it just like it was an equation. So we have y is greater than 1/2 x plus 4. So our y-intercept is going to be 4, and our slope is going to be 1/2. And then we would just connect the dots. And we just graphed the equation, right? If this were equals, we graphed it. But when we have inequalities, we have two things we want to consider. So one would be, do we have a dotted line, which would be if we have this greater than or less than, or do we have a solid line, be if we have greater than or equal to or less than or equal to. So you notice since this is greater than, we're going to have a dotted line. So luckily on the whiteboard it's really easy to turn solid lines into dotted. So question number 2 is, do I shade above our line, which would be greater than or equal to, or do I shade below our line, which would be less than or equal to? So in this case, we have greater than, which means that we are going to shade in above our line, and thus we have our inequality graphed. So for the rest of this lesson, we're just going to do more examples like this and just look at the different scenarios that we might find. So suppose we had y minus 1/3 x, let's do plus 1/3 x, is less than or equal to 6. So the way that I usually like to graph inequalities is I almost immediately try to put them into slope-intercept form. So that's, recall, y is equal to or greater than less than mx plus b. And that's because then it's really easy to figure out if we have to shade above or below. And as we went over in one of our last couple lessons, it's easy to graph when we have the y-intercept and the slope. So I'm going to subtract 1/3 x from each side, and we're going to get y is less than or equal to negative 1/3 x plus 6. Up 1, 2, 3, 4, 5, 6. Our slope is going to be negative 1/3. So our line is going to look like that. Dotted or solid line, it's less than or equal to, so we're going to have a solid line. And since it's less than, that means that we're going to shade below our graph. And that would be the answer to graphing this inequality. So what if we had, say, like 3y minus 18x plus 5 is, say, or let's make this a negative 3y. And let's say is greater than, let's see, negative 19. So in this case, we'd want to put it into this form. So I could start by subtracting 5 from each side. We get negative 3y minus 18x is greater than negative 24. Then I divide both sides by negative 3. And remember that our inequality rules do apply to two-variable linear inequalities as well. So we're going to switch this sign. We're going to get y plus 6x is less than 8. Subtract 6x from each side, and we get y is less than negative 6x plus 8. If we graph this one, 1, 2, 3, 4, 5, 6, 7, 8, our slope is negative 6, so it's going to look like that. Our line's going to look like that. We have less than, not less than or equal to, so I'm going to make our line a dotted line. And y is less than, so even though this line is pretty close to vertical, we can still see that less than is going to be on this side of the line, because it's under the curve. So that would be our answer to this inequality. You note we're just shading in either above or below the line to represent the coordinate pairs that would satisfy our inequality. Like for example, we see the point 0, 0 is shaded in this one. So we can check, is 0 less than negative 6 times 0 plus 8? Is 0 less than 8? Yeah, so that's why that point is shaded. Whereas if we were to pick a point out here, like say we were to pick the point 10, 10, we get 10 is less than negative 6 times 10 plus 8. Is 10 less than negative 52? No way, and that's why that point is not shaded. So that just kind of a little bit of the math behind why we're shading one side and not the other. And I want to just go through two more special cases. So suppose we're given just x is less than or equal to negative 3. So if we were to graph x is equal to negative 3, that would be a vertical line. So it's going to look like this. Since it's less than or equal to, we'd have a solid line. In this case, there's no above or below. But if we look at our number line, we have x is less than or equal to negative 3. So that means that no matter what y is, we're going to shade in all the x values that are less than or equal to negative 3. So we'd shade to the left. And if we had, say, x is greater than 2, it would be the other way around. This is just going to be a really small, quick graph, but we would shade in to the right. And similarly, if we have, say, y is greater than 4, this time, 1, 2, 3, 4, we're going to have a horizontal line. And if y is greater than, we would shade in this area above the curve. And if y were less than, we would shade in below. So that is how you graph linear inequalities in two variables. It's pretty simple. You just have to remember these two key concepts, that we have greater than or less than, we have a dotted line. It's greater than or equal to or less than or equal to, we would graph with a solid line, and then deciding whether or not we want to shade above or below the curve, or in the case of vertical lines, left or right. So that concludes this lesson. In our next lesson, we're going to kind of apply everything we've done with linear equations and inequalities so far and apply them to word problems and modeling real-world situations. So that's exciting stuff coming up.